And I thought a good thing to do this morning would just be a couple of very practical things. I know there's some really basic things, roadblocks or little problems that people have, and I mean I've been helping people with these issues for a period of time. I have a good sense of what some of them are, so I thought I'd just take a few minutes to mention a couple of small things that are helpful. So, actually, excuse me. Let me pause for a second. I was going to send an email this morning and I got distracted. Did you write to Annabeth? Did you write to Gordon?
Yeah, we wanted to know when would be time.
I mean, I don't know. I mean, I don't think we're going to go that late this morning. Probably people are going to burn out, but I mean, if you can tell them to come over at 10 or 10:30 or 11 or something, we'll be around. All right, so one of the things that is in the software that, well, there's tons of stuff in the software that's not obvious, and one of them is quite useful, and it's this package called Complex. And it already loaded, but one of the little tips is if you think there's some package that has stuff that you're interested in, if you load it again with double less than, you'll see the commands there, and basically this is a package that's, just write a few things on the board. So suppose G of R is a complex group. Then, there's these parameters x lambda nu, as always. And let me do an example. Let's say it's SP for C. Then G of C is SP for C cross SP for C. And a parameter is an x lambda nu, where lambda is an 8 tuple. 8, 4. 4 tuple. And nu is a 4 tuple. So for example, rho is 2, 1, 2, 1, because there's 2 copies of G. And well, for complex groups, there are more convenient parameters, which is better. And I'm going to write them as x gamma L gamma R, or x mu sub C nu sub C, where gamma L gamma R mu C and nu C are all 2 coordinates, A1, A2, 2 coordinates. And so in this notation, the trivial representation is equal to x of rho minus rho. Bad rho.
If we're in the Atlas world, you should put W0. I mean, the little x is W0, and
Well, but I'm not in the. I'm thinking this x notation because this is what I'm writing. One of these guys.
Okay.
And maybe this is where it gets confusing. I mean, this is rho R or something, rho R. So it's rho R minus rho R. That's the gamma L and gamma R, or alternatively, it's 0, 2 rho R. This is the mu C coordinates. And there's a number of people in the room that talk to me about complex groups that are familiar with this notation. And if you're not familiar with it, I'm not going to try and explain it now, but I wanted to just say how the atlas gives you access to this, so that if you're interested in complex groups, it makes them easier to think about. And so let's just do an example. So let's say G is equal to SP for C. And let's look at rho of G. As I said, it's 2, 1, 2, 1. And let's set P is the trivial of G. So P is, there's the KGB element, and lambda and nu are both rho. And by rho I mean four tuples. And the gamma L and gamma R coordinates for this representation are rho and minus rho, that's what I said here. And the mu coordinates, mu sub C, and nu sub C, are, as I said, 0 and 2 rho. And you can make a parameter like this. You can say G parameter for G with 2, 1, minus 2, 1. It's not dominant, which is a little bit annoying. If you have a non-dominant parameter, you should make it dominant by normal, and that's the trivial representation. So if you're familiar with making representations using gamma L and gamma R, or lambda L and lambda R in more common terminology, you can make a representation that way. The G stands for gamma, and there's also an M version. You do M parameter G 0, 0, 4, 2, and make it normal, and you get the trivial representation that way. And so let me just do one final example. Let's set B is equal to the block of the trivial of G. And yeah.
I have no idea what's going on.
Okay.
G parameter is parameter for.
So
Why is it non-dominant?
that's a little annoying. I should probably just build making the dominant into it. So it's an algorithm. There are sort of 3 different kinds of coordinates. There's a parameter x lambda nu in Atlas, and you can also write them as x gamma L gamma R, or you can write it as x mu C nu C, and it's just 3 completely equivalent parameterizations of parameters, irreducible representations for a complex group. This is general, but these 2 only exist for complex groups. And I just built into the software these arrows. And I need to improve them, I realize. They should automatically do this. This business about getting non-final parameters is just a mistake. I built in an algorithm to go from one of these to one of these, and it's giving you an equivalent anyway. It should be dominant.
So then you said G parameter. G
Yeah. So this is a G parameter, and this is an M parameter. So when I say G parameter, where is it? G parameter, I'm saying construct me a representation using these coordinates. And I put in rho minus rho, and I got the trivial representation.
The G stands for gamma.
Right. And the M
Where are
stands,
the coordinates of the result?
pardon me?
Where are the coordinates of the result? That's 0, 0, 0, 0, and 2.
Yeah, it's constructing in Atlas. Let me do it again. This is saying that in gamma coordinates, rho minus rho gets converted to atlas coordinates, 7 rho rho. And rho means two different things here. This is the 2 copies of rho, and this is the 1 copy. But this is atlas coordinates, and that's
Oh, it's transformed from G parameter.
from G parameter, right. So it goes both ways. You can take a parameter in atlas coordinates, and you can get its gamma L, gamma R, or you can define a parameter by gamma L and gamma R, and it converts it to atlas coordinates. I mean, everything in atlas, of course, is going to be done in atlas coordinates. I'm just giving you convenient routines for these other arrows.
Okay, so G parameter is kind of very input routine.
Exactly,
parameter.
exactly. Thank you for asking those questions. Is that clear now?
So the command normal also works for real groups.
Yeah, normal is a very general command. Excuse me. So there are various kinds of parameters, and there are various conditions on them: normal, final, and dominant. And there are commands for manipulating them. And one of them is normal, which says if you have a parameter which is not normal, it's equivalent to a normal parameter, and the command normal gives you an equivalent parameter which is normal.
Jeff,
Yes?
thank you very much for
You bet. Okay. And so let me just illustrate this with an example. Let's set I have the block of the trivial for P if B do like this P gamma sub L of P gamma sub R of P. So this is showing you if you take the ordinary atlas coordinates and convert them to gamma L and gamma R, what they look like. Excuse me. So these are the parameters in the block handed to you by Atlas. And they're a little hard to understand. Lambda is always rho, that's nice. But you have all these different x's, and then the n's are inscrutable. I'm sure I can screw them, but I don't see how at the moment. And if you're familiar with complex groups, you know that the block of the trivial is parameterized by the Weyl group. And that's what the gamma L, gamma R do for you. Gamma L is always rho, and gamma R is the W orders of rho. And up here is the length 0 guy where it's rho rho, and down here is rho minus rho, W naught rho, and then all the other conjugates in between. So this is a much more convenient way of thinking about complex groups.
But is there a kind of like asymmetry between L and R?
Well, so there isn't, but let me explain what that's about.
So what do L and R stand for?
Left and right.
Where is the M parameter?
Pardon me?
Where is you remember the M parameters?
M parameter means it's giving you the M parameter
M stands for
mu and nu. Does someone have a better terminology?
What kind of?
MU.
as
So mu is the lowest k type, and nu is the continuous parameter. This is telling you how to write this thing as induced from B up to G of mu tensor nu tensor 1. This is on S1 to the n, and this is on R plus to the n. And the G parameter, that's this x of gamma L, gamma R. This is Jelibenko's notation. And anyway, there's and so in this picture, x gamma R is isomorphic to x w gamma L, w gamma R, the diagonal action of w. And so if you want, excuse me, and the infinitesimal character is simply this pair, gamma L, gamma R. And up to W cross W. So if you want to know what all the representations of a given infinitesimal character are, let's say integral, so.
So there aren't really coordinates, because it could be anything.
I'll come back to that in a second.
Coordinates of a point.
Hang on, let me just say this and then I'll address your question. So, the representations with infinitesimal character gamma, assuming it's integral, are parameterized by, the set of W gamma L, Y gamma R, modulo W diagonal. And so, if you want, you could just, you can fix gamma L or gamma R, and the software decides to always keep gamma L fixed and move gamma R. Okay, your objection, Mark?
Well, so you actually, you're using the whole W orbit.
Yes,
Just in accordance to one point.
I'm choosing a point in the orbit, that's correct.
And that's the asymmetry, you're choosing the point where the left coordinate is prominent?
Yes. But if you can input anyone, the software will recognize it.
Yeah, and the fact it's called gamma is because it's related to the infinitesimal.
Yeah, that's this statement. The infinitesimal character is this pair. So this is gamma in Atlas notation.
If you take arbitrary pair, you get one gamma out of it. That's because gamma could have two.
Oh, there's a condition. I think what you're allowed to take is gamma L, gamma R, but gamma L minus gamma R is required to be an mix-up or sub.
I think maybe with a plus you want the take type,
Thank you.
and can you say, well, I have can you say which one is you said which was there's a normal parameter, but which one?
Well, normal is a general notion, and I have to think about what normal means here. Well, let's just do that example. Let's do, so this is a non-dominant parameter. Excuse me. So, it constructed this parameter, and this new isn't dominant. And I used the command normal, but maybe it would have been better to do dominance. Dominant replaces this with a different parameter, an equivalent parameter, which makes this dominant. And what it did is it applied, I think, the bottom developed over here. There's some twisted, it's twisted on here. There's some equivalence, and it changed the x. So I don't want to try and figure it out right now.
There isn't any torsion in lambda, is it?
No.
So it's basically just adding lambda plus mu, which is the infinitesimal character, and acting on that.
I'm sorry, say it again?
It's taking lambda plus mu, which is the infinitesimal character.
Yes.
And just applying while we're into that becomes dominant. And it's doing, at the same time, it's doing the corresponding cross-action of x.
But it must be doing W lambda plus rho minus rho on the lambda, because how's lambda changing? I mean,
You add lambda plus mu, you get an honest rational vector. You
Yes.
act on that, and,
Yes.
and at the end of the day, you compose it into the plus
Yeah,
and minus
yeah.
x space. That's it. In this case, because
So the answer to your question is, it's not so easy to understand what this is doing, and I don't know, it's complicated. All right, let me stop there. Okay, I wanted to do one other brief thing, and this is just programming, a fact about programming, and Mark gave several talks where he explained very carefully how the software works, and I'm much more, not nearly as adept at computers as Mark is, and I experienced over the course of the software development some trouble learning a few things, and various people here have asked me similar things. So just from a very practical point of view, I want to illustrate the one thing about the software which I think most people have asked me about, and I had trouble about in the past. So let me illustrate it with an example. Let's set G equal to SL2R, and let's set P to be the trivial representation of G, just for a place to start. And what I want to illustrate is there's this let in, let in, in syntax. It's totally obscure, but that's what I'm explaining, so let me show you. So let's say, for example, that I want to extract the x and the lambda and the nu from this parameter and do something with them, very elementary. Like just, what I'm going to do is I'm going to extract them, and I want to add lambda to row and print them out. That's a very simple thing that you might want to do that people have trouble doing. So let me show you how you do that. So the first thing you do is you extract x. So you say let x equals, well, actually, let me first do it this way. If you just want to see x, you say set x equals x of p. And that extracts x for you. That's fine. And similarly, you can set lambda is equal to, lambda is equal to lambda of p. And that extracts lambda.
You don't have to always set it to the variable first.
That's true. I could just say nu of p. And that extracts nu. Okay? But now if you're using these things in a loop or in a sequence of commands, that's where you need this let. You use this let syntax. So you say, for example, let x is equal to x of p in. Now hit return. And the software tells me this I is saying we're in the middle of an expression. We're not done. And I could also say let lambda is equal to lambda of p. And you always have to finish with another in. And let nu equal nu of p in. And then I'm done. So now I'm going to do what I want to do, which is print s lambda, x lambda nu. It's kind of a silly little thing, but I just want to illustrate something really basic. So it's this let in syntax. You have a sequence of commands, let in, and then at the end, you just conclude with the command. And the point is, at the end here, you define, the way you think of these in statements is x, lambda, and nu are defined, and they're being used in this last statement. This last statement is referring to those things which have just been defined. And if you look at the script, you see this kind of thing over and over and over again. And it's a little bit unusual syntax. It's the way the software is defined. It's extremely useful, but it takes just a little getting used to. Questions? Yes? Go ahead.
So the point is you do it in a for loop or something?
Yeah, for example, you would do this in a for loop.
It's not related to anything in particular. It's just a way to introduce local variables within a scope. In this case, the scope is the expression you're working in. But you could do for blah, 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 do, and then you say, okay, now I want I, which is loop
Yeah, so let me do an example.
In terms of that, then you can, in the loop, you can say, let something of I, and then work with that. And then it will, of course, end its validity at the bottom, which is good, because it's a local variable.
So let's do an example. So you say for I, up to 10, do. Well, let's just show how loops work. I. So runs from I from 0 to 9 and returns it as an array. Okay? Now, another thing you could do is within the loop, you could do something like print s I, and that, what does that do? That runs over the loop and it prints this. And now what's this about? Well, I ran over this loop, and what I did was this print statement, which returns a void value. So after it's done executing this, instead of having the numbers there, it just has a bunch of voids. So that's fine. And
Which we
now,
get rid of, we did that.
yes, you get rid of them by saying this.
You know, you're saying the whole for loop should be replaced.
Okay.
And void doesn't produce anything.
So let's do a let in here. So for I1 up to 10, do let j equal 2 times I. And now what do you want to do with that? Well, let's say in I plus j. So what did this do? It said take I is equal to 0, let j is equal to 0, and add them to get 0. And let I is equal to 1, and j is equal to 2, and add them to get 3, and so on. And if you look in the script, you'll see there's sort of deeply nested things like this with lets and so on. I just want to mention one. I want to go back to the example I did at the beginning. I said let x is equal to x of p. And this is some syntax which is very common. Then is just a synonym in let. So you have all of these in let pairs, and they get a little annoying, and so there's some syntax called then. So instead of saying the way I did before, I do it like this: let x equal x of p, then lambda is equal to lambda of p. Oops.
If you're going to type that at the end of the line, it's going to be that very
Well, it's too late for that.
The one place I cannot.
Okay. Let x is equal to x. Why is
Why
that?
don't you type, you used to type in line with 100 characters, you type then and then not say.
Okay, fine, let's do that. But we'll talk later. Let x equals x of p then lambda is equal to lambda of p, then nu is equal to nu of p in the triple x lambda nu. And so that's exactly synonymous, that's exactly the same thing as saying this. And so when you see these strings, you often see strings of then, da da da, then, and at the very end you need an in. And I'll show you one of the things that happen.
Because this example starts getting a bit tiresome. Can we do the variant where the then is a bit more useful?
Sure.
So let
Well, but before you do that, let me just illustrate one thing. If you make a mistake, you think you're done, but I typed then, and so it's got a let going now, and so it's still waiting for more. And you just have to remember that at the very end, you want an in instead of a let. Excuse me, then.
So the capital L tells me to let.
Yes, the capital L tells you that there's a let that's unclosed. Okay, go ahead, Mark. What do you want me to do?
So let's just do something other than decompose. So that actually, that point, then RD is root taken of X. Then roots is simple roots of RD in, and I want also the evolution of X. Then in for alpha equals to evolution theta, no theta prime alpha. No.
Oh, that's a little boring. Let's set P to be the trivial representation of SP6R. Okay, so let's unpack what Mark just had said. So, well, let's look at P.
Sorry, could you explain why only one root appeared?
It's because there's only one simple root.
We were in SL2R.
We're in SL2R.
Oh, okay.
Just a simple root. I mean, well, there's only one root, period.
Yeah, I was still back in SP4.
Yes. So let's unpack this. So we have this parameter, which is for SP6, it's x, lambda, and nu. And so you extracted x, and then you said RD is the root datum of x. And part of the point I think that Mark is making here is that the way I was doing it, I was just sort of extracting stuff from the original T. But here I got x, and then this depends on x, and then this depends on RD, and so on. So it's more of an interesting example. So anyway, so you get x, and then you find out what the root datum of x is, and then you compute the simple roots of the root datum, and then you calculate the involution of x, and now finally this is whatever I'm actually going to do something, I'm going to run this for loop, run over the roots, and do theta times the root. So this is actually,
Theta happens to be -1.
right, so let's just tinker with this very slightly. Let's say do the pair alpha, comma, theta alpha. Excuse me. So now you get these pairs. That's the first simple root, and that's theta of it, which is minus. That's the next simple root, and that's theta of it, and so on.
Did you change x to
Yeah.
36 or something?
Let's set P is the block of P bracket 25.
P.
Okay, so now I took the block, I took some other random parameter in the block of the trivial for this group. And so now